Okay, so hello students. Once again, we'll be discussing these questions. You can see some important questions for physics. That examination is on 10th December for class 12th term 1 examination. So these are the very important questions that will be helpful for you for your preparation. So let us see that questions and the answers. So without delaying time, so let us see the first question of the day. Yeah. So you can see here in the question it is written that magnetic field at the center of a circular coil of radius r through which current I flows. So all of you know that suppose one circular loop is there, you can see the circular loop. If here suppose I amount of current flows, if I amount of current flows, then if I ask you magnetic field intensity B is equal to, I think my writing is clear. All right, so it will be mu naught I by 2 into A, where A stands for the radius. Of course, here in the question, the radius is given R. Uh, so then B is equal to mu naught I by 2 pi A, and I think the answer is you can understand. So radius, here it is given that the field at the center of the coil of radius r through which the current I flows. So I think now you got that idea. So option C is the right answer. Yes, now let us go to the next question, and it is on the screen. You can see here on the screen it is written that you can see a long solenoid carrying a current produces a magnetic field B along its axis. So all of you know that suppose one solenoid is there. Okay, you can see my picture here. A solenoid, and B is the magnetic field produced around it. If the current is doubled, and the number of turns per unit centimeter is half, then the new value of magnetic field is what? So all of you know that the magnetic field at the center of the B is equal to mu naught Ni, and current will be doubled, and length per unit centimeter is half. Means you know that no, both two will be cancelled, and the answer will be same. Okay, so these are very basic level questions, and that will be helpful for you. So without delaying, let us go to the next question, and the question is on the screen. It is written here: the magnetic field around the long solenoid, a magnetic field around the long straight current carrying wire is what? Which type of? All of you know that if it is a long wire, then the symmetric will be what? Cylindrical symmetric. I think it is clear to you. All of you can understand now. So now with that, let us go to the next question. Yes, of course, this question is very interesting, and I'm giving you 1 to 3 second time to get the solution. I'm waiting for your answer. I'm waiting for a comment, then we'll quickly start that one. Yes, by the time I think you got the answer, let me get the solution for you. You can see I'm writing on my screen here, and you will get the solution here. All of you know that F is equal to QVB, since it is centripetal force also. So mv square by r. Now, if I ask you r, then all of you know that how much it will be? Mv square by qvb, and you know the answer. So finally, the answer is coming. Option D is the answer. It's very interesting questions, and definitely it is only basic and direct formula based question. So let us go to the next question. Yes, of course, this question is very interesting, and you can see this side 1 by 40 centimeter actually. Option D, 1 by 40 centimeter. You can see that I'm reading the question for you. Yes, a beam of electrons is moving with constant velocity in a region having simulate simultaneous perpendicular electric field of strength something, and magnetic field of strength something is given here. So electric field is given the 20 volt per meter, and magnetic field is given what 0.5 Tesla, respectively. The at the right angle to the direction of the motion of the electrons. Yes, Lorentz force. Yes. So then the velocity of the electron must be what? Four options are there. So let us find out the answer. Since the electric field and the magnetic field perpendicular to each other, because of electric field, the force acting will be how much? QVB, and the force because of electric field. This is QVB is because of magnetic field, and because of electric field, it will be what? QE. Now, what you have to find out? The velocity. If I ask you velocity, V will be what? QE by QB. So final what will happen? QQ will be cancelled and it will come how much? E by B. So how much electric field is given? 20, and how much magnetic field is given? 0.5, and the answer you can find out. So if it is going 200 by 5, yes, 200 by 5, so 5 4 40. So option C is the right answer. You can get the solution. Nice, very interesting. So with that, let us go to the next question, and the question is on the screen, and this is direct formula based question. And the question it is given that two thin long wire parallel wires. Okay, so separated by distance d, and current carrying is I. Both the wires same amount of current is flowing in the same direction. So then what will be the four options are there? What will the right answer? Yes, and it is direct formula based question. You know, if current is flowing in the same direction and same amount, there will be force of attraction, and the answer, direct answer, you can find out. Yes, direct formula based. So here the answer is B. Okay, very interesting. Now let us go to the next question. There is no question. My whiteboard is empty. Anyway, so I'm taking to one more question. Yes, question is on the screen, and I am here at the corner. And here is the question is very interesting. It's written here, three wires A, B, C. You can see three wires are there. Wire A, wire B, and wire C. You can see my backside wire is there. So three wires A, B, C are situated at the same distance. Both, that is, all the wires are in the same distance, but the difference is that in A, 1 ampere current, and in B, 2 ampere current, and C, 3 ampere current flows in the same direction. Then the resultant of force on B is directed towards what? B means this middle. On the middle wire, what will be the force? So as you know, the direct formula based question, force is what? Force depends upon what? Product of I1 into I2. Already we know that one. So if it is there, so in which case the product will be maximum? Of course, B and C. So then you know that the answer is in your hand. Very interesting question. And with that, let me take you to the next question. And the question is on the screen. And this question came in CBSE 2020. This question came, you can see that question. And the question is on the screen. You can read. I'm going to read for you. The magnetic dipole moment. Yes, magnetic dipole moment of a current carrying coil doesn't depend upon what? Four options are there. And let me see your comment. Quickly, I'm waiting for your comment. So it is a direct formula based question. So I'm giving you the option and I want comment from your side. Once I'm getting the comment, I will reply you. All of you know that whatever the comment you are writing in the comment box, immediately I do reply. So that is my nature. Okay. So with that, let me take you to the next question. There is no question. My screen is clear. Anyway, so let us go to the next question. It is similar question and the question is on the screen. The magnetic dipole moment of a current loop is independent of, means doesn't depend on what? Four options are there. Then once you read, I'm going to explain you. So we know that magnetic dipole moment. Magnetic dipole moment denoted by capital M is the product of I into A, where I stands for current and A stands for area of the coil. And also it depends upon the number of turns. Can I say NIA? Yes. So depends upon number of turns, depends upon current, and depends upon area. And doesn't depends upon what? Doesn't depends upon what? Magnetic field. And you got the answer. This is also direct formula based and conceptual understanding question. Anyway, so with that, let us go to the next question. It is very interesting question on the screen. You can read once. A current carrying loop is placed in a uniform magnetic field. The torque, yes, the torque acting on it doesn't depends upon what? Four options are there. So quickly reply me, please. Yes, by the time I think you have written the comment. Anyway, let me explain you. So when a current carrying loop is kept in a magnetic field, the torque acting, we know that torque is equal to what? N I A B cos theta. My writing you can see here on the screen. So where N stands for number of turns, I stands for current, A stands for area, B for magnetic field, and cos theta, you know that angle between. So above all, we can see what is the answer? Option A. So shape of the coil. It is not depending upon the geometrical shape of the coil. It depends upon area. Yes, area of the loop and value of the current and magnetic field. And finally, option A is the answer. Then sometimes your comment will be there. Key if the shape is there. For example, one coil is there. If shape is becoming big, area will become also big. So that is not the relative answer here. Okay, so you can comment me, definitely I will answer it. So with that, let me go to the next question. Very interesting question. A square current carrying loop is suspended in uniformly magnetic field acting on the plane of the loop. If the force on one arm of the loop is F, the net force on the remaining three arms of the loop will be what? See, if one rectangular, I can use my mobile here. Okay, so if one force is acting here in this direction, this on this two arm, no force will be acting. So here what? Same force, because it will be rotating. If your F amount of force, your negative F amount of force will be there, and you can find out the answer. Option B is the right answer. Now it's a very big question. Okay, so once you read that one, an electron is projected. An electron is projected with uniform velocity along the axis of a current carrying long solenoid. Which of the following is true? So four options are there, and quickly comment me which one is the true. Yes, you know that suppose one long solenoid is there. I am drawing the diagram on the question, and you know this is the direction of the magnetic field. You know this it will be uniform in between. Suppose one electron is entering and it is moving in the same direction. An electron will be deviated from its path if any force is acting on it. So if I say that force F is equal to QVB sine theta, I think you can understand my writing. QVB sine theta. And sine theta is the angle between what? Velocity of the charged particle and the magnetic field. So here the velocity in the same direction and magnetic field also same direction. Then the angle between them is what? So then you can understand. So option D is the right answer. Okay, so with that, let us go to the next question. Very interesting question, and the question is on the screen. I'm going to read for you. A galvanometer of resistance 100 ohm gives a full deflection with current 10 to the power minus 5 ampere. To convert into emitter capable of measuring up to 1 ampere, we should connect the resistance of what? Four options are there, and I'm waiting for your comment. So here we can see galvanometer resistance is given 100 ohm, and the current can be measured is how much? 10 to the power 5 ampere, and the maximum current is how much? 1 ampere. So all of you know that I'm writing here S is equal to shunt. S for shunt is equal to Ig into Rg, current in galvanometer and resistance of the galvanometer, divided by I minus Ig. So if I write here, so current in the galvanometer how much? 10 to the power minus 5, and the this is multiplication. Okay, just 1 minute. So into Resistance of galvanometer, how much it is given? 100 ohm. Can I write 10 to the power 2? Yes. And which is divided by current, total current 1 ampere, and the current that can be tolerated by galvanometer is 10 to the power minus 5. So if you calculate how much it is coming, 10 to the power minus 3. So then I think, and this is the shunt parallel, so the answer is B. Yes, you got the answer. With that, let me take to the next question, and the question is on the screen. An electric charge in uniform motion produces what? Electric charge in uniform motion produces what? 4 options are there, and I am waiting for your answer. Yes, by the time I think you have written the comment, if a charge in the state of rest, it can produce only electric field. If a charge is in the motion, it can produce what? Both electric field and magnetic field. And the answer is in front of you, option C. Yes, with that, let us go to the next question. It is very interesting question and similar to the previous question also. A galvanometer having the resistance 80 ohms is shunt by the wire of 2 ohm resistance if the total current is 1 ampere. Here this one is, where is that? Is 1 ampere. The path of the current passing through it will be what? 4 options are there. I think you can calculate this one. I'm giving you hints, option C, and write me in the comment. I will be explaining in the next class. Okay. Besides that, let us go to the one more question. The question is on the screen. A resistance of an emitter is 13 ohm and its scale is graduated for the current up to 100 amperes. After an additional shunt has been connected, shunt parallel, connected to this emitter, it becomes possible to measure up to 750 amperes by the value of shunt resistance is what? So directly we can apply that formula. Just I want to show where I will draw this one. Suppose this is the resistance of the emitter and this is the shunt. You can understand my diagram. Okay, so the resistance is 13 ohm and it can measure up to 100 ampere. Here shunt we don't know, I am writing S, and maximum amount of current how much it is coming, 750, but 100 ampere will be flowing through the emitter, then the remaining 650 will be passing through the shunt. So then both are in parallel connection, so here both the case potential will be same. So can I write 100 into 13 must be equal to S into 650? Yes. Then finally if I ask you S, then what you will be doing? 100 into 13 by 650. So then 0 0 cancel, 13 5 ja, 5 2 ja. So 2 ohm, option A is the right answer. Okay, so with that, let me take to the next question. It's a very interesting question. An electron moves in a circular orbit. In a circular orbit with uniform velocity v, it produces a magnetic field B at the center of the circle. The radius of the circle is directly proportional to what? 4 options are there, and let us see. As we know that the radius is equal to what? mv by qb. I hope you are agree with me. Here mass of the electron is constant and charge is also constant. Then R will be proportional to what? V by B, velocity selector. Okay, and of course this year cyclotron is not in the syllabus, and this is also a person in cyclotron. So I think option D is the answer. Yes. With that, let me take you to the another question as on the screen. So in this question, a charged particle of mass m and charge q travel in a circular path of radius r that is perpendicular to magnetic field B. The time taken, yes, time taken by the particle to complete one revolution. Yes, this is directly formula based question. Option C is the answer, conceptual. So when we learned about their circular motion, qvb sine theta and mv square by r, if you equate, then time taken means what? Distance by velocity. If you put, then you will find out the answer. So now one more question is there on the screen. A charge q is moving with velocity v parallel to a magnetic field b. The force on the charge due to magnetic field is what? Parallel. Then you know the answer. Yes, in the comment box I can get option C is the right answer. Now, one more very interesting question. This question is for you, and answer I'm waiting from you. Yes. So, dear children, daily we'll have these physics classes. Okay, and in these days we'll be discussing only for CBSE question, because on 10th we have examination, and once the exam over, again we'll start our NEET and JEE classes. Okay, so these questions answers you can I'm waiting from you, and next question we'll discuss now. So this question is on the screen, so let us find out the answer.